What is the Oort cloud? Okay, A, why does it exist? B, how big is it? C, does it exist around every solar system? And D, could it have helped in evolving life in our solar system? So let me give you a visual idea of what the Oort cloud is. Let me share an image. Okay, this is a rough model of the solar system. So here, if you can see my mouse pointer, that's the sun. Here is the Earth. So this distance between the sun and the Earth is called 1 astronomical unit. So this graph is on the logarithmic scale. So this is 1 astronomical unit. This is another 10 astronomical units. 10. So this is the distance between the sun and the Saturn. This is 100 astronomical units. That's where the Voyager 1 spacecraft is roughly around right now. So that is basically where the solar system ends. That's the beginning of interstellar space. And the Oort cloud is a hypothetical spherical cloud of basically icy objects that are the nuclei of future comets. So that is what the Oort cloud is. It is an enormous cloud. Let me show you a different image. Okay, so let's take a look at this. So if you look at this image here, the red orbit here is that of Mars, the green one is Earth. This diffuse orbit over here is the asteroid belt, and the orange orbit here is the orbit of Jupiter. If you look at it here, it's very small, the orbit of Jupiter, and the purple one is the orbit of Pluto. And you have the Kuiper belt over here. And this red dot is the minor planet called Sedna, which is currently around 90 astronomical units from the sun. 1 astronomical unit is the Earth-Sun distance. Here you have the orbit of Sedna, which is an enormously elongated orbit. Yeah. So it tells you how small the orbit of Pluto is in comparison. Let me remove that, right? So that gives you an idea of the orbit of Sedna. And this is the orbit of Sedna in comparison with the Oort cloud. So that gives you an idea of how large the Oort cloud is and how far away it is from us. It's essentially in interstellar space, but it is still under the influence of the sun's gravity. It's an enormous cloud, hypothetical enormous cloud of cometary nuclei, the nuclei of comets. Now, what happens is that if this Oort cloud does exist, and there is a good chance that it does exist, so if this Oort cloud does exist, then it is only loosely influenced by the sun's gravity because it is so far away from the sun. It's essentially in interstellar space. And it is also affected by the gravitational attraction of nearby stars, passing stars, and also the gravitational attraction of the Milky Way itself. And therefore, you see that from time to time, various cometary nuclei get dislodged from their orbits, and some of them are sent tumbling towards the sun. And that's what eventually becomes comets. So this is basically a hypothetical reservoir of comets. So it's almost halfway to the nearest star. That's what the Oort cloud is. So it's hypothetical, but there's a very good chance that it does exist. And it exists because of the way the early solar system formed. The solar system formed from a primordial cloud of gas that was left behind from the death of another star. So the solar system is a reincarnation of a previous solar system, and the material that was left behind after the circumstellar disk coalesced into the sun and the planets, that became the Oort cloud. Initially, it is believed that it was much closer to the sun, and eventually it drifted out further away from the solar system, from the sun, because of the gravitational interactions of the gas giant planets. Okay, so it's quite far now. It's in interstellar space. It's very, very large, but it's very diffuse. Does it exist around every solar system? There's a good chance that it exists around many stellar systems. We haven't really seen, because it's such a small, diffuse. It's not small, it's very large, but it's very diffuse, and the cometary nuclei therein are very, very small. So it's almost impossible to detect around other stars and even around our own solar system, which is why it's still hypothetical. But if it exists around our solar system, there's a good chance it exists around other solar systems as well. Could it have helped in evolving life in our solar system? Well, we spoke about panspermia, this theory that microscopic life exists across the galaxy on dust grains and comets and asteroids, etc. So, if some of these cometary nuclei did contain the seeds of life, then it could have seeded life on the Earth in the very early solar system when the Earth was under intense bombardment from comets and asteroids. So, there is a possibility that it may have played a role in the seeding of life in the early Earth.